Hi, and welcome to the Calculus 1 lecture series. And we are doing the unit number 3, the applications of differentiations. And this is our lecture number 19. And in this lecture, we're going to talk about one very important theory. We call this the mean value theories here. Okay. And so let's go ahead, go to our lecture note, and let's go ahead and get started. Okay, so the first thing here is before we talk about the mean value series here, then we're going to talk about what we call the Rolls theory. And then this is a special case of the mean value series here. Okay, so now let's try to take a look at what is the Rolls series here. Okay, so let's first take a look. So if the function f, we have a few conditions. The first conditions here is this function is continuous on this closed interval AB, and the second condition here, this function is differentiable. Okay, on this open interval AB is here. Then the third one is here. We have the two ends point FA equal to the FB here. Then we know then there is at least one number C, okay? And this number C is in this open interval AB, and such that we have F prime C is equal to 0 here. All right, so a few things, let's be careful, right? So it's differentiable. So it will be differentiable in these open intervals. And also, that means the Rolls theory tells you that list a C on this open interval such that F prime C equal to 0 here, okay? So before, so what is the meaning of this Rolls series here? Let me draw a picture, I think, and then that will kind of make a lot of sense to you. Okay, so take a look here. Okay, so for example, here, I have a functions here. So this one's here. Let's say here, this is my A, this is my B here, all right? So let's see here, if I have a function, it's a continuous from the A to B, and also it's differentiable to the A to B here, okay? So they say here, so that means if I have a function like that, and then let's say the FA equal to the FB here, right? So this point here, this is F of A, and then also is equal to F of the B here. So the Rolls theory tells you because it is differentiable, right? So when we talk about differentiable, that means what? I don't have any sharp corners, right? So that's why, if this is the value, because it's a continuous and differentiable. So that means at least 1 point. So that means you could have here and here, right? So that means you can find because they're going to turn, right? So that's why that's why it means you can find the tangent line with the what? With the, you can find the tangent line with the slope equal to 0, right? So this is my C's here. That's what is Rolls series tell you here, right? So that means if FA equal to FB, that means the unit is continuous and differentiable. So you have to make a smooth turns here, right? And then that's why you can find at least one. Okay, so now what is the mean value series here? Mean value series is a generalization of the Rolls theory, or Rolls series, a special case of the mean value theory. Okay, let's before I write it down, the definition, let's take a look from the graphing point intuitively what that means here, okay? So in here, if this is my A, this is my B here. Okay, so now if I have some smooth function go like this. Okay, so let's say here I have some smooth function and I have some smooth function go here. Okay, so this is my f of A and this is my what? F of what? F of the B here. Okay, so what is the mean value theory tell you here? Let's take a look at the graphic meaning, then the definition will be easier. Okay, so this is my functions, right? So they tell you, okay, so now if you connect the two ends point, right? If you connect these two ends point here, you will get this green lines here. So what is the mean value theory tell you? Mean value theory tells you, hey, you can find another line, another tangent line, which is attached to this graph, but also is parallel to this green line. So that means I can have a tangent line here, right? So this is my tangent line. That means one of my C's here, right? That's what that means. Or you can say here, I can have another C's here, right? So that means when you find the tangent line will be parallel to the, the green line. So when you mean parallel, what's that mean? That means the slope is the same, right? That's the generalizations of the rows series here. So if FA not equal to FB here. So here we said the functions. So if the function F, so the first couple conditions is the same. So we say it's continuous on this closed interval AB. And we also say this is differentiable on the AB, right? So that means differentiable, that means it has to be smooth turns, right? So you cannot, you cannot have sharp corners or some things, right? So then we will say also the third one is here. So the FA does not necessary to be equal to the FBs here, right? So the F of A and F of B, not necessary to be the same. So that means they can be the difference here. Then we say, then there is at least one number C in the open interval AB such that F prime C. So this ones here, we said such that this F prime C, that means this is F prime C, right? So it'll be equal to this green, the slope. What is the green slope? Rise over run. So it's F of B minus F of A and B minus A. So, right? Okay. So now let's what we talk about the mean value series here. So that means at least we can find one point. At least it could be like for this example, I have 2 points here. Okay. So now let's start with the basic, very easy one. They said number one, they say, hey, mark the x-axis to see the mean value series for the function. Okay, so we know the mean value series. That means if you connect these 2 points, right? So you will get a line. See here, this is my green line. So it will tell you, you can find in these curves here, you can find some tangent line, parallel to this green line. That means they have the same values, right? So here, this is, so in here, I can find like two C's, right? So here, this is my C1, this is my C2. That means I can find 2 places here. Then if you find the tangent line, and the lighter tangent line will have the same slope as the one you connect the 2 ends point. Okay? Okay, now let's take a look here. So the number 2, it tell you here, they said, hey, do the hypothesis and the conclusion of the mean value theory hold? Then let's check here. So f of x is here. Okay, so the f of x is what type of the function? This is what? It's a polynomial, right? Because x and x cubed, right? So fx is a polynomial. So what's that mean? That means a polynomial. That means f of x is what? Is a continuous, okay? And because it's a polynomial, also the f of x is differentiable. Okay, now let's take a look at f of the 4. Okay, so the f of the 4 is 12 minus 3 to the 4 to the cube here. So I have this one here, I got it is negative 28 over 3. Then f of the negative 1s here, right? So negative 1 is 3 times negative 1 minus 3, the negative 1, the third. Okay, so we'll give you negative a over 3 here. Okay, so now let's try to find this green curve, right? So the slope here will be equal to f of the 4 minus f of negative 1. So 4 minus negative 1. So far, so good. All right, so if you figure, so this will be negative 4 over 3 here. Okay, so that means this is negative 4 over 3. So this green line. So now I know I can find a c here. So how do I do that? So, okay, so I say f prime x equal to what is 3 minus what? X squared. So by the mean value theorem, I know this one going to equal to negative 4 over what? Over 3 here. So I can solve it. So I can say x equal to the 3 plus 4 over 3. So it's 13 over 3. So now x will be equal to the square root of the 13 over 3, or x equal to the negative square root of the 13 over 3. But since negative 13 over 3 is not belong to in this interval negative 4, right? So what is my final answer? So I can find my c value is square root of the 13 over 3 here. Okay. Okay, now let's take a look here. Okay, so the number 3 here say find all the number c that satisfy the mean value theory. So f of x, so the first things here we say f of x is what type of the function? Is a polynomial. If it's a polynomial, so what do we say? F of x is what? Is continuous, right? So polynomial is continuous. And the second condition, f of x is what? Differentiable, right? That means everywhere is smooth. There's no sharp point here. Okay, so now the mean value here. First, I need to find the end value. So f3, so it's 27 minus 27 plus 3, so it's 3. Okay, right? So the f3 and now f0, oh, the f0 is 0, 0, 0, so it's 0. So the slope will be f of 3 minus f of 0, 3 minus 0. So it's 3 minus 0, 3 minus 0. So what is the derivative here? The derivative is 1. Another one, the slope is 1, right? So we know the mean value theory tell me, so this is the slope of the two endpoints. So the mean value theory tell me the derivative will be equal to the 1s here. So let's take a look at f prime x. So what is f prime x? It's 3x squared minus 6x plus 1. And we say, hey, it's going to be equal to what? Equal to 1s here, right? Then you move the 1 over, so you got a 3x squared minus 6x equal to 0. So you got a 3x out, you can have x minus what? X minus 2 equal to 0. right? And then you say set this one equal to 0, this one equal to 0. So I will find the x equal to 0 and the x equal to 2. But x equal to 0, this will not be our solution. Why? Because x0 is a boundaries, right? So we set a mean value series. So x equal to 0 not belong to the open interval 0 and 3. It's correct? So that's what is this symbol not belong to. So it's a, because it cannot be at the boundary. So x equal to 2 is my only values here. All right, so the x equal to 2, that means I have a c values, right? So c values here is 2. Okay, let's take a look at how these the applications here work. So it said Dave is driving a highway that has a speed limit 55 miles per hour. Then at the 2 p.m., he is at the milepost 110. At the 5 p.m., his milepost is 290. Is there enough evidence to prove Dave is guilty of speeding somewhere? Right, so the speeding, that means at a certain moment, his speed is more than 55 miles, right? So the first thing is let's take a look here. Say the first milestone, the 2 is 110. The second one is 5 and the 290s, right? Okay, so I know I have the 2 points here. One is 2 at 110, and the other one here is 5 and the 290s, right? So I know the slope of this will be equal to what? The slope of this will be the 290 minus 110 and the 5 minus 2. Okay, so I will have in here, I will have 60s here. So I will have the 60s, right? So now, okay, so I know by the mean value series, right? So we know there is a C inside this interval, and this inside this interval is what? Inside this interval is 2 and 5, okay? Such that f prime c is equal to what? 60. So remember, right, we said f prime, if f is a position function, then f prime is the velocity, right? So at that moment, right, so let's at this c moment, the speed is 60. So we know, so that's why we know that he is guilty of the speeding, right? So that means we have a c value, and this is 60s here. Okay, so we know the velocity. I'm sorry, I shouldn't write it this way. I said, so that means the velocity at c at equal to specific value is equal to 60. So we know this is what? So we know Dave is speeding, was speeding, right? So that we probably is guilty of speeding at some moment, right? It's speeding between where and where in these intervals here, right? So it's speeding there. Okay, now let's take a look at other ones here. So this is another application. So it says, hey, suppose f prime x is less than 0, it exists, and f prime x less than 2 for all the x. Let's say if f1 equal to a, so what is the largest value that f5 could be? See here, okay? So we said because f exists everywhere, right? So we know that because f prime x exists, okay? So then we can apply mean value series, right? So we can apply the mean value series of f on this closed interval 1, 5 here, right? So we know f prime c, just like we said, the endpoint, one is 1, another is 5, right? So this will be 8 minus what? F of 5. Well, let's do f5 first. Okay, so here. Let's write it out so you will not get confused. So this is f of the 5 minus f of the 1. So this is 5 minus 1, right? So this one's here, this is f of the 5 minus 1, so minus 8, right? And this is a 4. So because by the mean value theorem, we know exists a C, right? So for such, this is true. But every derivatives here, look here, right? It says all the derivatives less than or equal to 2. So what is this one here? We say, hey, this one is less than or equal to 2. All right. So that means f of the 5 minus 8 less than or equal to 8. Then the f of the 5 is less than or equal to 16 here. So we know the f of 5 at most, it's what? At most can be 16, right? Okay, so the same idea for the mean value theory. Okay, the last ones here, let's take a look. They said if f of x equal to gx for all the x, is then the derivative are the same or not? We say true, right? So if let's say f prime x equal to the gx for all the x, then f of x equal to gx is true or false. So it's a false. The reason why is, let me give you examples, right? So let's find the contradiction examples here. Okay, so if I have f of x, right, equal to, let's say, x cubed minus 3x squared plus 3, all right? Then the fgx here, let's say the gx here, then the gx here is equal to the x cubed plus 3x squared plus 5, right? So obviously they are not equal. So let's take a look at f prime x. F prime x, this is 3x squared plus what? 6x. Let's take a look at g prime x. What is g prime x? 3x squared plus 6x. Oh, wow. The both of them the same, right? So both of them the same. But is the f prime fx equal to the gx? No, they are two different functions, right? So the f of x not equal to the gx, right? So even f prime x equal to the g prime x here. So this one is false, okay? So this lecture is a pretty simple lecture. We talk about the mean value theory. So basically, it's like if you have, this is the geometric meaning, is have way more meaning, kind of can help you to understand exactly what is the mean value try to tell you, right? It just tell you, if you have a continuous and a very smooth differentiable function, then you connect the two ends point, you have lines, right? This is my, the green line. And then they say you can always find at least, right? So that means what happens here? So at least, that means you can have more than one. Then if you take the points, the tangent lines there, and it will give you what? It will give you the same, like the same slope as this green lines here. All right, that's it. Okay, so looking forward to talk to you in our next video. Okay, bye.